Sea Dragon. The Sea Dragon was a proposed super-heavy rocket designed during the 1960s. At roughly 150 meters tall, it would have been one of the largest rockets ever conceived. It was significantly taller than Saturn V, the rocket that carried astronauts to the moon. Engineers wanted to reduce launch costs by using a simpler design than traditional rockets. Unlike most rockets, Sea Dragon would have been assembled at sea. It was also designed to launch directly from the ocean. This approach could have eliminated the need for expensive launch facilities. Sea Dragon was designed to carry hundreds of tons of cargo into orbit. Some proposals suggested using it for future moon missions. Others imagined it supporting human missions to Mars. Despite its potential, NASA never provided enough funding for development. The project was eventually abandoned before construction began. VentureStar. VentureStar was a proposed reusable spacecraft developed by NASA and Lockheed Martin during the 1990s. The project aimed to revolutionize space travel by creating a vehicle that could reach orbit without discarding boosters or fuel tanks during flight. This concept, known as single stage to orbit, had never been successfully achieved before. Unlike traditional rockets, VentureStar was designed to launch, deliver payloads into orbit, return to Earth, and fly again with minimal refurbishment. Engineers believed this could dramatically reduce the cost of access to space and make launches far more frequent than they were at the time. To prove the concept, NASA funded the development of an experimental prototype called the X-33. The X-33 was intended to test many of VentureStar's most important technologies, including its lightweight structure, advanced engines, and unique lifting body shape. However, serious problems soon began to appear. One of the biggest challenges involved the spacecraft's large composite fuel tanks. These tanks were designed to be lighter than traditional metal tanks, but they repeatedly failed during testing and proved far more difficult to build than engineers had expected. As development continued, costs increased and schedules slipped further behind. Technical difficulties continued to accumulate, making it increasingly difficult to justify the project's growing budget. By 2001, NASA decided to cancel the X-33 program. Without a successful prototype, VentureStar itself had little chance of moving forward. The spacecraft was officially abandoned before a full-scale vehicle could be built. Although VentureStar never flew, many of its ideas influenced future reusable spacecraft concepts. Today, it remains one of the most ambitious attempts to create a fully reusable spacecraft capable of reaching orbit in a single stage. Constellation Program. The Constellation Program was NASA's plan to return astronauts to the moon after the retirement of the Space Shuttle. Announced in 2005, the program was intended to build a new generation of spacecraft for deep space exploration. At the center of the program were two new rockets called Ares I and Ares V. Ares I was designed to carry astronauts into space, while Ares V would transport heavy cargo and equipment. NASA also developed the Orion spacecraft, which would carry crews beyond low Earth orbit. Unlike the Apollo missions, Constellation aimed to establish a long-term human presence on the moon. Future lunar bases were expected to support scientific research and prepare astronauts for missions to Mars. Engineers spent years developing hardware, conducting tests, and refining the program's design. However, the project soon faced growing technical challenges and rising development costs. Schedules slipped further behind as NASA struggled to keep the program on track. Independent reviews concluded that Constellation would require significantly more funding than originally planned. As costs continued to rise, concerns grew about whether the program was sustainable. In 2010, the United States government decided to cancel most of the Constellation program. By that point, billions of dollars had already been spent on development. Although the program was canceled, several of its technologies survived. The Orion spacecraft continued development and later became part of NASA's Artemis program. Today, Constellation is remembered as one of the most ambitious lunar exploration programs that never reached completion. NOVA rocket. NOVA was a family of giant rocket concepts studied by NASA during the early years of the space race. The rocket was designed as a possible successor to Saturn V and was intended to carry much larger payloads into space. Several different versions of NOVA were proposed, with some designs standing well over 100 meters tall. At the time, NASA was searching for the best way to send astronauts to the moon. One option involved launching a massive spacecraft directly toward the lunar surface using a single enormous rocket. To accomplish this mission, engineers began developing concepts for rockets far larger than anything that had ever been built before. NOVA quickly became one of the leading candidates. Some versions were capable of carrying hundreds of tons into orbit, making them among the most powerful rockets ever proposed. Compared to Saturn V, NOVA would have been significantly larger and capable of launching much heavier payloads. Engineers believed this extra capacity could simplify future lunar missions and support even more ambitious exploration plans. However, NASA eventually selected a different approach, known as lunar orbit rendezvous. This method allowed astronauts to reach the moon using the smaller Saturn V rocket. Once Saturn V proved capable of accomplishing NASA's lunar goals, the need for NOVA largely disappeared. As a result, development of the giant rocket was gradually abandoned. No NOVA rocket was ever constructed, and the project never moved beyond the design stage. Although it never flew, NOVA remains one of the largest and most ambitious rocket concepts ever studied. Many space enthusiasts still wonder what might have been possible if the giant rocket had been built. NERVA program. NERVA was a nuclear thermal rocket program developed by the United States during the Cold War. The name stood for Nuclear Engine for Rocket Vehicle Application. Unlike conventional rockets, NERVA used a nuclear reactor instead of chemical combustion to generate thrust. Inside the engine, the reactor would heat liquid hydrogen to extremely high temperatures. The superheated hydrogen would then be expelled through a nozzle, producing powerful thrust. This method was far more efficient than traditional chemical rocket engines. Because of its efficiency, spacecraft using NERVA could potentially travel farther while carrying less fuel. NASA viewed the technology as a promising option for future missions beyond the moon. Some proposed missions even envisioned using NERVA-powered spacecraft to send astronauts to Mars. Throughout the 1960s, engineers built and tested several experimental NERVA engines. Many of these tests were successful and demonstrated that the technology could work in practice. At the time, NERVA was considered one of the most advanced rocket propulsion systems ever developed. However, public interest in ambitious deep space missions began to decline after the Apollo program. NASA's budget started shrinking as national priorities shifted elsewhere. Without a clear mission that required nuclear propulsion, support for the project gradually faded. In the early 1970s, the NERVA program was officially canceled. Although it never flew in space, NERVA remains one of the closest humanity has come to building a practical nuclear rocket. Many engineers still consider it one of the most promising propulsion concepts ever tested. Soviet Moon Base. The Soviet Moon Base was a proposed plan by the Soviet Union to establish a permanent human presence on the moon during the Cold War. Following its early successes in space exploration, Soviet engineers began studying ways to send cosmonauts to the lunar surface and keep them there for extended periods. Unlike the brief Apollo missions, the goal was to create a long-term settlement where crews could live, work, and conduct scientific research. The project envisioned multiple habitat modules connected together to form a small lunar outpost. These habitats would provide shelter, life support, and working space for cosmonauts operating on the moon. Engineers also proposed lunar rovers and specialized equipment to help explore the surrounding landscape. Some concepts included expanding the base over time as more missions delivered supplies and additional modules. The moon base was intended to serve as both a scientific laboratory and a symbol of Soviet technological achievement. Throughout the 1960s and early 1970s, several designs and mission plans were studied in detail. However, the Soviet lunar program suffered from repeated setbacks and technical difficulties. The massive N-1 rocket, which was intended to carry cosmonauts toward the moon, failed during all 4 of its launch attempts. At the same time, the United States successfully landed astronauts on the moon through the Apollo program. After losing the race to the moon, Soviet interest in large-scale lunar projects gradually declined. Economic pressures and changing priorities made an expensive lunar base increasingly difficult to justify. Without a reliable rocket capable of supporting the program, progress slowed dramatically. By the mid-1970s, plans for a permanent Soviet moon base were effectively abandoned. Although it was never built, the project remains one of the most ambitious lunar settlement concepts ever proposed. Mars Direct. Mars Direct was a proposed human mission plan developed in the early 1990s to send astronauts to Mars. The concept was created by aerospace engineer Robert Zubrin as a simpler and more affordable alternative to other Mars mission proposals. Instead of assembling enormous spacecraft in orbit, Mars Direct relied on a relatively straightforward mission architecture. The plan called for an unmanned spacecraft to be sent to Mars before the crew arrived. Once on the Martian surface, this spacecraft would produce fuel using resources already available on Mars. By manufacturing fuel locally, the mission could avoid carrying large amounts of return fuel from Earth. After the fuel production system was confirmed to be working, a crewed spacecraft would launch toward Mars. Astronauts would then land on the planet and spend more than a year exploring the Martian surface. The mission aimed to maximize scientific research while keeping costs significantly lower than many competing plans. Supporters argued that Mars Direct could make human exploration of Mars achievable using technology that already existed. The proposal gained considerable attention from both engineers and space enthusiasts. Many experts praised its simplicity and practical approach to interplanetary travel. However, the mission never received the funding or political support required for development. Concerns about cost, risk, and long-term commitment prevented the project from moving forward. As the years passed, Mars Direct remained a concept rather than becoming an active space program. Although it was never implemented, many of its ideas later influenced modern plans for sending humans to Mars. Today, Mars Direct remains one of the most famous and influential Mars mission concepts ever proposed. Energia II. Energia II was a proposed reusable version of the Soviet Union's Energia rocket system. The project was developed after the successful launch of the original Energia rocket in the late 1980s. Unlike the original design, Energia II was intended to recover and reuse major parts of the rocket after launch. Engineers hoped this would significantly reduce the cost of future space missions. The rocket was designed to work alongside the Buran space shuttle and support a wide range of payloads. Like its predecessor, Energia II would have been capable of carrying extremely large cargo into orbit. Some plans envisioned using the rocket to launch space stations, lunar missions, and other ambitious projects. At the time, Energia was one of the most powerful launch vehicles ever built. The Soviet space program hoped that a reusable version would make heavy-lift launches more practical and affordable. Engineers began studying ways to return rocket components safely back to Earth after each mission. However, before the project could move beyond the planning stage, major political and economic problems emerged. In 1991, the Soviet Union collapsed, triggering a severe financial crisis throughout the country. Funding for many large space projects quickly disappeared as priorities shifted elsewhere. Without sufficient resources, development of Energia II came to a halt. The reusable rocket was never completed and never flew. Although the project was canceled, it remains one of the most ambitious reusable rocket concepts ever proposed by the Soviet Union. Today, Energia II serves as a reminder of what the Soviet space program might have achieved if it had continued beyond the end of the Cold War.